Now that we've learned how to break down a polynomial function, let's build a polynomial function from given roots. So the first thing that we're going to want to do is determine the degree you will end up with. And I mostly just do that so that I know when I get to the end that I've included all of the roots that were given. And there's a special note here. Make sure that you include the conjugate pairs. And you remember which kind of roots have conjugate pairs. The conjugate pairs go with irrational and complex roots. And then also be sure to include multiplicities. So let's look at an example. For the example, I am going to provide you with the roots. X equals -1, and that's going to have a multiplicity of 2. And we're also going to have the root x equals 3i. So what will the degree be? Let's count them up. I have x equals -1, that has a multiplicity of 2. So right here we have 2 roots, and then x equals 3i is another root, and then this is a complex root. So even though they didn't list it, we need to include one more root. The conjugate for x equals 3i will be x equals -3i. So the degree is going to be 4. After we have counted up how many degrees we're going to have, how many factors we're going to have, the next thing that I am going to do is convert the roots to factors. And then I'm going to write out my function in its factored form. So I'll start with f of x equals. Now the root of x equals -1, x equals -1, I add that 1 over, so I get x plus 1 equals 0. So that gives me x plus 1, and since that's there twice, I'll have x plus 1 listed 2 times. X equals 3i. I'll subtract the 3i over, and I get x minus 3i equals 0. So that factor is x minus 3i. And then the conjugate will be x plus 3i. Then the next thing we are going to do is we are going to start multiplying that out. So I will say FOIL your compatible roots, the compatible root pairs, I would say. What I mean by that is if you have any complex ones, complex times complex, or irrational times irrational, you should do those pairs times each other first. So I'm going to be multiplying the x minus 3i times the x plus 3i, and I will also multiply the x plus 1 times the x plus 1. So I'll do those two pairs first. So f of x equals x plus 1 times x plus 1 gives me x squared plus x plus x plus 1. So I'm going to get x squared plus 2x plus 1. X plus 3i times x minus 3i will give me x squared plus 3ix, and then minus 3ix, and then minus 9i squared. So the plus 3ix and minus 3ix cancel each other, and negative 9i squared, remember that I squared is -1, so that becomes x squared plus 9. So after I've done that, then I will FOIL my new parentheses. And at this point, the box method might become helpful. So I can do x squared, 2x, and 1 times x squared plus 9. And I get x squared times x squared is x to the fourth, and then 9x squared here, and then 2x cubed, and 18x, and 9, and x squared. So my final function will be x to the fourth plus 2x cubed, and then 10x squared plus 18x plus 9. And you always want to write that in standard form if possible. I just want to do one more example that's like this, but I'm going to take this from a different approach. We are going to go from a graph, and we are going to, given the roots, write a possible f of x. So we will put, I'll have a root here. One here, one here, and this one I'm going to label that one as 3 plus the square root of 5. Okay. Oops, I actually wanted this to do that. Yikes. Sorry about that, guys. So we'll just scribble that part out. We'll pretend it just wasn't ever there. Maybe I'll cover it up. There we go. Not there. Okay, so let's look at our roots that we have on this graph. Here we have 3 plus square root of 5. Here we have x equals -3. And since it bounces there, that has a multiplicity of 2. And we have this one that we don't know what it is, although we do know that we have 3 plus square root of 5. So this one has to be 3 minus square root of 5, since those irrational ones go in pairs, just like the imaginary ones. So what will the degree be when we're all done? We have 1, 2, 3, 4. So this degree will be 4. So I'm going to start listing my roots. I have x equals -3, x equals -3, x equals 3 minus square root of 5, and x equals 3 plus square root of 5. I want to convert those into factors. Remember, I do that by moving that number over. So I'll add 3 over to that side, and I get x plus 3. I'll add the 3 over, I get x plus 3. Now these ones, I'm going to have to subtract the 3 over and also add the square root of 5, so that I end up with 0 on this side. So this will actually be x minus 3 plus the square root of 5. And then this one, I'll subtract the 3 over, so x minus 3, but I also subtract the square root of 5, so it'll be x minus 3 minus square root of 5. Now the same approach is going to hold as it did before. I'm going to multiply these two together, and I'm going to multiply the ones that are compatible together. But I'm going to tell you that I will use the box method right away to multiply my two irrational roots. So I will take x minus 3 and the square root of 5, and then x minus 3 and minus square root of 5. And I'll put that together in a multiplication table format. And then I'll take x times x to get x squared, x times -3, -3x, x times negative square root of 5, negative x square roots of 5, x times -3, -3x, -3 times -3, 9, -3 times negative square root of 5 will be positive 3 square roots of 5, square root of 5 times x, x square roots of 5, -3 times square root of 5, -3 square roots of 5, and negative square root of 5 times positive square root of 5 is going to be negative square root of 5 times square root of 5 is regular old 5. So what you should see happening here is that the irrational parts actually cancel. The negative x squared to 5 and the positive x squared to 5, and the negative 3 squared to 5 and the positive 3 squared to 5. So from that part, I end up with x squared minus 6x plus 4. And then I'll just FOIL this like normal. X squared plus 3x plus 3x plus 9. So that gives me x squared plus 6x plus 9. And then all that's left to do is to superfoil or do the box method or triple distribute, or however you prefer to multiply two trinomials and combine their like terms. So I'll have x to the 4th, negative 6x cubed, 4x squared, 6x cubed, negative 36x, 24x, 9x squared, negative 54x, and 36. So f of x will be x to the 4th. The x cubed terms actually cancel. I have 4x squared and 9x squared, so 13x squared. Negative 54x and 24x would be negative 30x, and then I have this negative 36x. Oh wait, that should be negative 36x squared. So let's back that up again. F of x equals, I had a little mistake there, x to the 4th, and then 9 minus 36 plus 4 will be minus 23x squared, and negative 54 plus 24x would be minus 30x, and then plus 36.